To solve equations that have one variable in them, so they're called single variable equations, we're going to perform operations on both sides of the equations. So in this first equation, you'll notice that we have terms that have x in them on both sides. The very first thing that we want to do is to take the two sides of the equal sign and do the same operation to both sides to create what's called an equivalent equation. So we're going to subtract off 2x from both sides of the equal sign, and I put it underneath its like term. So we have 5x's and we subtract off 2x's, we have 3x left, and there's still a plus 4 on that side of the equation. And then on the left side of, on the right side of the equation, we have 2x minus 2x, which is 0, and we still have the minus 11 left. Now we're going to subtract off the 4 from both sides of the equation, and we'll again put that underneath its like term so it lines up. What's left now is 3x equals negative 15, and the next operation we'll do to create an equivalent equation is divide both sides by 3, and that'll give us x equals negative 5. What's important to realize is that all of these steps here, the steps are what are considered equivalent equations. All of these equations are made true by the value x equal to negative 5. All right, let's try B. Very similar. We have variables on both sides. So if you want to, if that's helpful, just draw that a light line down there in the middle so you know what we're talking about when we say do things to both sides of the equal sign. And so we're going to work with our variable terms first. So one thing we can do is we can subtract n from both sides. If we subtract n, we have 5 still left on the left side, and negative 3n minus n is negative 4n, and that equals, on the right side, n minus n is 0, and we still have 5 left. And then we're going to subtract 5 from both sides. Now be really careful here. This 5 right here is a positive number because the minus sign is on its right side, not its left side. We always look to the left of the number to determine the sign. So that 5 is a positive 5. So in order to do the same thing to both sides, we're going to subtract 5 from both sides. What that's going to leave us with is negative 4n. Remember to bring that negative on the left of the 4n down, equals, and 5 minus 5 is 0. Now the next thing that we're going to do is we're going to divide through by negative 4. And 0 divided by negative 4 is 0. 0 divided by any number is 0. So we get n equal to 0. Also, we can think of this last step as saying this step is negative 4 times what, that's our n, equals 0. And the number that needs to go in that blank is 0. That's what we're finding when we find the value of n. All right, let's take a look at another example. In C, 8 minus 6c equals negative 6c plus 2. We are going to do the same thing to both sides, and you can move whichever variable you want. So we have a negative 6c on the left side of the equation. I'll draw that vertical line down here. And then we have a negative c on the right side. So you can either add c or add 6c. Let's try adding 6c first. That'll move the variable to the left side or to the right side of the equation. So 8 minus 6c plus c is 8 on the left side, and then equals negative c plus 6c. Remember, there's a 1 in front of that c on the in the original equation. So we have negative 1 plus 6 is 5c plus 2. And then subtract off 2 from both sides because we want the variable to be isolated on one side of the equation. So 5c equals 8 minus 2 is 6. Now, don't worry about the fact that if we divide by 5 to isolate c, to get c equals a number on the right side, that we don't have a whole number on the left side. That's okay. You can just leave your answer in improper fraction form 6/5. That's also 1 1/5, but in algebra it's easier to leave your solutions in improper fraction form if it comes out that way. Also, do not be tempted to change your answer to decimal. That's not necessary and not desirable. All right, let's take a look at a harder one. In D, we have more terms. So I'm going to draw this line first, and the very first thing I want to do is just to simplify both sides of the equation. I'm not going to subtract or add anything. I'm just going to simplify. So let's take our like terms, negative k and 5k. That's 1k and 5k are 6k plus 6 equals. And then on the right side of the equation, we have positive 10 minus 4. So that's going to be 6 plus 6k. Now let's subtract our variables off from both sides. So in order to move this 6k on the left side, we can subtract 6k from both sides of the equal sign. That'll give us 6 equals 6. Now remember what I said before, we have an equation that is equivalent. That means each of these equations, the original one, the second equation that we wrote, and the last equation that we wrote, they all have the same solution. That is, they have the same value of k that makes them true. Well, 6 equals 6 is always true no matter what the value of k is. So what that means about k is that k can be any real number. So I'm going to write that our solution set here is the set of all real numbers. All right, in E, we have another equation where we have some things that need tidying up on both sides of the equation. So I'll draw that line down the center with the equal sign. And on the left side of the equal sign, we have a -1 and a -4. They're going to combine together to give us -5. And then on the right side, we have a +2 and a +5. They're going to combine together to give us 7. And then we still have that -3y. Now remember to pay attention to the signs. The 3y on the right is negative and the 3y on the left is positive. So we can move those by adding 3y to both sides of the equation. That'll give us 6y minus 5 equals 7. And now we can add 5 to both sides of the equation so that the y term is becoming isolated. 7 plus 5 is 12. Finally, undo that multiplication with division, and y is 12 over 6, which is 2. All right, let's take a look at one more example here. A plus 7 minus 5a equals 2 minus 4a minus 5. I'm going to draw a vertical line down the center with that equal sign so that we can talk about sides of the equal sign. On the left side, we have a positive 1a and a minus 5a. That adds up to negative 4a. And then on the right side of the equal sign, we have a positive 2 and a minus 5 that are like terms. They add up to negative 3. And we're going to bring down that minus 4a as well. In order to move one of the minus 4a's, we'll have to add 4a to both sides of the equation. And negative 4a and positive 4a add up to 0. So on the left side, that just leaves us with 7. And on the right side, it leaves us with negative 3. Remember what we talked about, we have equivalent equations that all have the same solution. So what value of a, the variable, makes the equation 7 equals negative 3 true? No value can make it true because that is a statement that is never true. 7 is never equal to negative 3. So what that means is there is no solution to this equation. All right, that's it for this part.